recording the lectures. I did a better job on the first day. Last class period, I kind of neglected to do so until the second half of class, but I'll be much more on top of them. And posting the recordings, I would put them on YouTube first, and then I'll post the links in this part of our modules. And I'll also do my best to, when we're in breakout rooms, not really record them, because then I feel like people are more likely to have their cameras on and more likely to kind of share what they're doing with their other classmates. So that's where you'll find those. What else? Oh, the survey that I mentioned. I briefly mentioned a survey on day one, and I mentioned 100 things on day one. So I very much understand if you haven't had a chance to do it or just forgot to. But there is this survey, the attitude survey. It should probably take you maybe 5-10 minutes. It's very important for the funding of college algebra, so we can develop cooler activities, we can develop better content, and honestly better syllabi and stuff like that. So please, 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 if you have a chance over the next couple of days to complete that. One other thing before we start content. First assignment is due this. The first is Monday. So it's due Monday at midnight. That is a quote unquote review assignment. I'm sure there's stuff in that. I don't really know why this is here. I think that was an old requirement. You don't have to get an 80% or above. I mean, you should. That's should be doable, and it's going to benefit your grade, but it's not required to do that to do any of the other homework assignments. And so I have office hours today if you need help on that. If you've kind of forgotten to do that, that's fine. I have office hours on Monday as well. I mean, at this point, you probably know a couple people in the class, so it'd be a good idea to reach out to them and maybe do a short study group or something like that to kind of complete these together, because definitely work together on these, work together on the in-class assignments. The only thing you really shouldn't be working together on are the exams. Any questions? Great. What did we do last time? May have already just recently talked about it.
Completing the square and quadratic formula.
Yeah, completing the square and quadratic formula. And so to kind of put a bow on this entire quadratic formula thing, we are going to talk about something called the discriminant. And so the discriminant is something that is, it's one of those concepts in college algebra that is kind of important once you get into higher levels of calculus, but it's almost kind of a shame that we float it out there and then say, okay, that's it, we're done with the discriminant, let's move on. Because on the surface, what the discriminant tells us is it tells us what type of solutions we're going to get. So it's very much related to this quadratic formula thing we talked about last time, the whole negative b plus or minus the square root of b squared minus 4ac all over 2a. And so this is the discriminant. You may notice that in the quadratic formula, it's what's under that square root. This is what's under the square root. And so the reason that we talk about it, at least in this class, is it's going to allow us to, instead of having to solve through all of these quadratic formulas and do a lot of that orders of operation, have to deal with square roots, blah, 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 blah. We can just find this discriminant, and if it's a positive, it will tell us we'll get 2 real solutions. We've seen a lot of that. That's actually the most common thing that we see. If it's a 0, we only have 1 real solution, which I think we've seen maybe once or twice on the in-class assignments. And then it's kind of a good thing that Rachel did go over this in recitation. If it's a negative sign, we get 2 imaginary solutions, which we don't really know what those are yet. Don't be super concerned about them, but that is a thing. It's not a real number. You're not going to get something like 4. You're not even going to get something like 2 plus or minus the square root of 3. So that's what's going to happen if you get a negative discriminant. And so if you really want to, since we don't know what imaginary solutions are, you could just write, we would get no real solutions. Either one's fine. Not really equivalent, but as far as what we know, they're essentially equivalent. And so just like when we did the quadratic formula, if we're going to solve one of these, if we're going to determine the discriminant, we have to identify what our A is, what our B is, and what our C is. So what's my A for this guy?
2.
2.
2.
Great. What's my B?
1.
Close.
-1.
-1.
Negative. So we have that kind of invisible 1 in front of our X. We have to keep the sign since we're subtracting the X. So yeah, my B is -1. Finally, my C is
-12.
and then I just plug it in. And like I said, this is kind of the simpler version of the quadratic formula. So it's not going to be too difficult to go through the order of operations. My B is -1, so I replace this with -1. It's a good idea to put in a parentheses. I talked about this last time because there's a lot of signs flying around. And so if we don't put that negative in parentheses, we'll probably just square the 1 and not really get it correct. So put that -1 in parentheses when you plug in to B squared. My A is 2. My C is 12. -1 squared is
1.
One.
Negative
4 times 2 is
8.
8.
times 12 is
96.
great. And 1 minus 96 is -95. Now, the weird thing here is that this question actually doesn't tell us to find the discriminant. Yeah, we kind of have to find the discriminant to answer the question, and it's a good idea to answer to kind of justify your choice, but the choices or the answer is going to be one of these things. Is it going to have 2 real solutions? Is it going to have 1 real solution? Or is it going to have, we don't know what 2 imaginary solutions are, no real solutions? And so if this is -95, this is -1, if this is -1 million, I don't really care that much about the number. I only care about the sign. So what's my final answer? What is the number and type of solutions for this quadratic equation that I'm not solving? I'm not going to go beyond what I'm about to write.
So it'd be 2 imaginary solutions slash no real solutions, but isn't the C negative? So that would actually give us 97.
Yeah, I was going to say that.
Yeah, I totally meant to do that so you could catch my mistakes. Great, so that will change my answer to what? No longer no real solutions.
I have 2 real solutions now.
Perfect. And if we wanted to, if we're feeling super motivated, we could throw this into the quadratic formula. We would get something like 1 plus or minus the square root of 97, and we would get 2 real solutions. But that's kind of overkill. We're only concerned about the information of, do I have 2 real solutions? Will I get 1 real solution? And will I get 2 imaginary slash no real solutions? So any questions about this? Great. So if you want to, you can, I think there's 1 or 2, there's probably like 3 or 4 questions on that 1.3 part 2 worksheet involving the discriminant. As I mentioned, the kind of unfortunate thing is we put it out there and then we say, okay, well, great, we're done with it. There might be 1 question on the exam. So I'm not going to spend a lot of time getting you guys to practice this. Instead, we're going to move into 1.5. And 1.5 is solving radical equations, or it might be called solving square roots, depending on what iteration of the book that we are on. And this is pretty similar to what we were doing with solving with square roots. Like if we had x squared is equal to 19, well, we got the x squared by itself and we would square root both sides. Now when we have square roots, well, our first step is to isolate the square root and then square both sides. So let's slightly adjust this question. So if I have something like this, square root of x minus 3 minus 2, I can't really go about solving this yet. I have a square root, I have a number. So my first job is to get the square root by itself. And so I do that by doing what?
Adding 2 to both sides.
Mm-hmm. And now I want to undo the square root. And what's the opposite of a square root?
Square both sides of the equation.
Mm-hmm. So once I square root both sides, well, that's going to get rid of my square root on the left side. So I'll just be left with x minus 3. And then 2 squared is what?
4.
That's my last step.
Solve for x by adding 3 to both sides.
Mm-hmm. Now, something that is strange about square roots is that everything up to this point, and honestly, the majority of the things we'll see in this class, once you get the final answer, once you, assuming you've done everything correct, your answer is going to be right. Like, it's always a good idea to check your answer, but you don't need to necessarily check your answer. And that's no longer true with square roots. Anytime we have a square root, we're going to check our answer because, well, some answers just don't work. Does anyone have a reason maybe why if I plugged in something for a square root, I could get an answer that just doesn't really work?
If it's not like a pretty like square root where it has an actual number.
That's true. I mean, it's still going to work. It's not going to be a lot of fun to check the answer. That is possible, but I'm going to get answers that no matter what I do when I plug it in, it's not going to work. I'll let you guys think about it. I'll let that marinate while we check our answer here. So I got x is equal to 7. How do I check my answer?
Plug it back in.
Mm-hmm. Take my square root. Go back to the very original part of my question. I plug in my 7. 7 minus 3 is 4. Square root of 4 is what?
2.
2. So my answer works. And that's what we're doing with checking our answers. Sometimes people try and overdo checking our answers, and we try and move things over to one side and multiply something from the left to the right. Really what you're trying to do when checking your answer is simplify each side almost individually. And then at the end, if you've simplified everything as much as possible and your answer is correct, they will match. So in this case, our 2's are correct. And so then our final answer is also going to be correct. So our final answer is 7. A quick way to box this. I'll do it this way. Great. Any questions about the first example? Cool. We're going to follow a very similar process for question 2. What's my first step? This guy here. How do I go about solving this equation?
Would you still start by subtracting x on both sides?
Positive 6, negative x. I'm going to adjust this slightly. Otherwise, I won't really get a nice answer. So apologize for people who write in pen in their notes. This is going to make it a nicer answer. Okay. What's my next step?
Now we'd square both sides.
Mm-hmm. Now what?
Add 6.
Oops. Correct. Why are you adding 6 though? Just so I kind of have a roadmap of the goal right here.
Because you want to get x by itself, so you would start with that and then divide by -5, right?
If I do that, then I'm still going to have this x squared over here, which is going to kind of be an issue. So I do agree the first step is adding 6. I'm not sure that I'll get a final answer of just an x is equal to something. Oh, sorry. Someone's using my printer. One sec, I'll mute myself.
So would you add negative x squared to both sides since that's supposed to be a negative?
So it's not supposed to be a negative, right? Because if we square, just to go back a step.
You're right. My bad. That makes
No,
sense.
you're good. I like where your head's at. I'm glad you brought it up. And so if I square the negative x, I will get a positive x squared. So that thing is correct as well. Well, let's think back to our first lecture when we were dealing with squareds. What did we have to do when we were trying to solve an x squared with other stuff around? There was something that we generally did unless we were completing the square, which we could do here if we wanted to, but it's more difficult than we need to do.
Set the equation equal to 0.
Exactly. And so how would I set this equation equal to 0?
Wouldn't it be easier to add the 5x and add the 6?
There we go. I'll actually do another line for the people taking notes. And so, yeah, going back to, I'm not sure who originally said it. Yeah, we're going to add the 6 over. And we are also going to add the 5x over. And we can do it in 2 separate steps if we want to. I feel like we're comfortable enough with our algebra to add the 5x and add the 6 over in 1 step. Great. Next step.
You begin factoring, no?
Yep. Are there any other options we can do? I agree factoring's the best option. It's really simple in this case. Are there any other ways I could solve this?
Couldn't you plug it into that quadratic formula?
Yep. Is there another way I can solve it?
Complete the square.
Yeah, exactly. So those are all options just to be aware of, but might as well keep it simple. And this is a very factorable question. So I want 2 things that multiply to get me 5, add to get me 6. You want to have an idea what those numbers are.
3 and 2.
Okay, next step.
You'd set both of those equal to 0 and then solve for x.
Mm-hmm. And it's fairly simple to solve for x. I subtract 3 from both sides. So I get x is equal to -3 and x is equal to -2. And I think this one works out too. Okay. So what do I do now? I box my answer and call it a day. Good job, Zach.
No, it's a radical equation, so you have to plug it back in to make sure it works.
Yep.
So you don't have any extraneous solutions.
Mm-hmm. So just so everyone's on the same page, extraneous solutions is a really fancy way of saying it doesn't work. And so we're going to check to make sure our equations or our answers work. So in this case, we plug it back into our original equation all the way up here. In this case, I might do it a little bit quickly since we've already seen it. I was hoping this example wouldn't work, but I believe there is stuff on the worksheet that doesn't work, so you will see it on your own. So if I plug in -3, get -5 times -3 is +15. Running out of space here. I'm gonna move this guy up here. -6 is 9. And 0 is equal to 0. So this guy works. I'll spare you guys the arithmetic on person if you want to. On paper, it's not a bad idea for your notes to check -2 also works. So both of these solutions work. I can't stress it enough. On the exam, we really like to make sure you check your answer. So I can almost guarantee that not only will a question like this show up on the exam, but also the question that we're going to ask you will require to be checked. And otherwise, you're going to miss that one of the equations doesn't work. Okay. Let's do one more. Now we can have cube roots. So that's why I'm thinking maybe the title of the section isn't solving square roots. It's probably solving radicals. So if we have a cube root, the process is almost exactly the same, except for once we isolate the cube root, well, instead of squaring both sides, we cube both sides. So that's exactly what I'm going to do here. So I'm going to cube both sides. It's going to cancel my cube root on the left, so I'll be left with 1 minus x. And 2 cubed.
-8.
Yep, -2 times -2 is 4, times -2 is -8. Great, almost done. What do I do next?
You'd want to get the x by
Right.
itself, so you'd subtract 1 from both sides.
Sure. And what do I do for my last step?
And divide both sides by -1.
I get x is equal to 9. Now to circle back to that question that I kind of threw out there and told you guys to marinate on. When you're dealing with cube roots, you actually don't have to check your answer. I mean, it's always a good idea to check your answer. If you have the time, do it. But if you do everything correct, you actually don't need to check your answer. It's always going to work, assuming you didn't make a mistake, which can be generous at times. So now I'll ask the question again now that we have kind of more things going around. So I don't have to check my answer when I'm dealing with a cube root. I do have to check my answer when I'm dealing with a square root. Can anyone think of why that might be the case? Yeah.
Because when you square a number, there's 2 possible solutions for it, both the negative and the positive version of the number.
That might feed into it, but I don't know why that would make it so my answer doesn't work, right? Like, it seems like I could possibly have 2 solutions. In fact, I can, like both of these work.
Mm-hmm.
I like where you're thinking. Anyone else have an idea? Might have to do a little bit like here. Something we talked about here, or something that you maybe talked about with Rachel. It has to do with domain. I can't really, at least what we know up to this point in class, I can't have a negative square root, or I can't have negatives under my square root. So that's the big reason of why I need to check my answer is the domain of square roots isn't everything. I'm not allowed to have a negative under my square root, where with cube roots, I can have any number. I can have a negative number. In fact, this when plugged into here would get me a negative thing, which is fine. I can get an answer. So that's kind of just something to be aware of. That's also not something I'm gonna super test you on. It's just, you know, a little high level question for you to think about. Cool, any questions? Great. Breakout rooms. To be a broken record for one last time, I'm going to put you in random groups. Make sure you are aware of the people you like, the people you don't like. I'm going to start to form groups over the weekend. I'll probably try it out on Monday and then maybe set things in stone on Wednesday. So just be aware of that.
Hey there. So I have to be on Zoom on my phone because that's the only thing that has a camera work.
Okay, so if you didn't perchance for some reason in your group, perchance, I don't know why I said that, get to question 3, that's a really good question to get done. That's a really good example of you find an answer that doesn't necessarily work. So that might be something, if you have some time after class or sometime tomorrow, just go ahead and work through that equation. Okay, and so oddly enough, in this section, for some reason, the book just kind of tacks on absolute value equations. So we're going to quickly cover that. This is going to probably be another unfortunate one-off where there might be one question like this on the exam, and maybe you will see some absolute value questions later on, but it seems a little bit detached from the actual section. And so what a lot of people do when we're solving or when we're doing absolute value equations or just absolute values in general is we think, oh, an absolute value just makes everything positive. It's just always going to be positive, which is kind of true in a sense, and it's definitely true when we're evaluating equations, but that's not always true. And so I go into this a little bit more in the video, but what absolute value means is it's the distance from 0. And so when we're solving for absolute values, usually there's 2 things that are like a distance of 3 from 0. Positive 3 is a distance of 3 away from 0, but so is negative 3. And so this kind of actually has a little bit of a flavor of this section and also a little bit of a flavor of the square roots. The square roots, we also had that plus or minus thing that we had to account for. And so just like square roots, when we're solving absolute value equations, our first step is to get the absolute value by itself. So how do I do that in this first equation?
Add 5 to both sides.
So then I will get positive 2. And now, instead of kind of square rooting something or squaring something, to get rid of my absolute value, all I do is immediately go into this plus or minus thing. But to be extra careful, instead of doing that cute and fun plus or minus thing in front of the 2, we're just going to break it up into 2 different equations. So one of them is my thing could be equal to a negative 2, my absolute value. And then the other possibility is it could be equal to a positive 2. So really what I'm doing here is I'm bringing down my equation. One of my equations is going to remain unchanged. It's going to be the exact same thing as my original equation, except for now we don't have these things. And then the other one is going to be the exact same thing as my original equation, except for I just have the negative. So that's where we get that feel of the plus or minus when we've been dealing with square roots. And now I go about solving. So let's just focus on the left equation. How do I solve the left equation?
Solve for x.
How?
Add 1 to both sides. And then divide by 2 on both sides.
I will get x is equal to -1/2. And then very similar over here, we're going to solve it. So instead of subtracting 1 from both sides, we're going to add it. I guess we added both sides on the other one. And then divide by 2 again. Now, something people were discussing in a breakout room is when we have fractions, can we put it as a decimal and round? I don't like that. Should I reduce your fraction? You should always, always, always reduce your fraction. So if this was like 6/4, this should not be here anymore. If this was like 6/4, then you should reduce it to 3/2. So if you can, always reduce your fractions. And that's my final answer. Yes, it's always a good idea to check your answer. No, this isn't the case where you could solve something completely and your answer won't work. So we're not going to do that in this case. Okay, very similar process with question 2. What's my first step?
Adding
Subtract.
2 to sides.
I think I heard someone say subtract 5, and I'm going to take that answer. Next step.
Oh.
Would you divide by 2 on both sides?
Perfect. So our goal is to isolate the square or the absolute value. We want to get the absolute value by itself, just like we did with square roots, just like we did with squares. All of that's exactly right. And so that's what we're doing here is we want to get this guy by itself. We have done that. We had to subtract the 5 over. We had to divide both sides by 2. But at the end of the day, now we have our absolute value by itself. And now this is why, in my guess or my theory, that it is included in this section, is at this point, I actually don't have to do any more work. My answer is no solution. Does anyone have an idea as why? It's another kind of high level question.
Is it because your answer would end up as a negative or something?
I can have negative solutions, right? I have one right here.
Oh,
Your
yeah.
absolute value makes it, you can't have a negative distance from.
Yes, exactly right. Yeah. So we talked about how absolute value is distance from 0. Well, it'd be weird for me to go to my friend and say, oh, I'm -2 miles from your house. That doesn't make any sense. We can't have a negative distance. So once we go about isolating our absolute value, if that guy, whatever it is equal to a negative number, it's no solution. Now it's important to emphasize I have to get the absolute value by itself first. So on this first equation, I can't just jump and say, oh, I have a negative on one side, I have an absolute value, so it's no solution. No, we have to get the absolute value by itself first. And then if it is equal to a negative number, great. You don't have to go through the splitting up into 2 equations and solving. You're just done. No solution. Any questions about that? Great. So we finished 1.3. We finished 1.5, which has both square roots and absolute values. And actually, we're going to finish 2.1 because it's a very small section and I'm kind of surprised it's its own section. And so that means, and I'll kind of adjust the schedule accordingly, that 2.2 is what we're going to start on Monday. So you may have watched the video for that already. If you want to review it again, great, but that's what we're going to start with. We'll probably also get into lines and stuff like that on Monday. So be sure to watch 2.2 and 2.3. Okay, so see if we can get this done in 5 minutes. So 2.1 is really 2 formulas. It's the distance formula and it's the midpoint formula. And so to kind of give that the context, well, if we're doing a distance formula, and let's say we have a point here and we have a point here, we're asking like, what is the distance from that point to that point on our graph? And then if we're asking for a midpoint, like let's say one of our points is here 1, 2 and negative 1, 2. Well, the midpoint is the point between those 2 points. And so the way that I remember the midpoint formula is it's actually just an average, which kind of makes sense. We're thinking about the average between these 2 points. Let's get this to be an equation. And so with that in mind, does anyone know what the midpoint formula is? This one's probably a little less well known.
x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. That's 2 separate equations for your points.
Yeah. And so that's what I'm talking about. I'm not great at memorizing formulas. And so I just kind of remember, oh, the midpoint's the point between the 2. So I take the average. I add the x1 to x2. I divide it by 2. I add the y1 to y2. I divide by 2. So if you haven't seen this x1 and this x2 notation before, all of that's really telling us is I'm going to take this first x, which is -3. I'm going to take the second x, which is 2. I'm going to add them together and divide by 2. So let's do exactly that. And what's my y1?
It's 2.
Y2?
6.
And then -3 plus 2 is -1. I'm just going to leave it as 1/2. If you really want to write that as a decimal, in this case, it's not different from -1/2. If this was 1/3, it would be a bad idea to write it as a decimal. So let's just get in the habit of leaving them as fractions. And then I have 2 plus 6 is 8. 8 divided by 2 is what?
4.
And then if you're halfway decent at graphing, and we'll do a little bit of graphing practice on Monday, if you really want to check your answer, you can just plot the -3, the 2, 6, and then plot your midpoint, and well, it should be the middle between those 2 points. Any questions about this?
The parentheses are required, right?
Yes.
Okay.
Yeah, you need to put those because it's a point. Midpoint's a point. It's not like a single value. But I'm glad you
I
got
always
that.
forget that, and I lost like points for that in high school.
Yep, and you will continue to lose points for that in this class. That's not going to go away. Okay, distance formula. Anyone know that one? This one's a little bit more complicated.
Isn't that one x2 minus x1 over 2, and then never mind.
It's close. It's a good start. We are going to have a square root.
Yeah, no.
We're going to have an x2. Oops. We are going to have an x1.
And then you add the y2 minus y1.
We are super close. We are missing something.
It's squared. The parentheses is squared. Both of them.
Which makes sense for a couple of reasons. One, we're dealing with distances. So we have to have a positive distance. One way to make sure you get a positive value is square everything. Squares are always going to return positive values unless we're dealing with imaginary numbers. So that's one of the reasons. And I think I go into this a little bit more in the video, but this is actually the Pythagorean theorem in disguise. So again, I'm bad at memorizing things. I mean, this definitely gets into the realm of it's not a bad idea to just have this in the back of your brain, but I kind of fall back to, oh, okay, that's actually the Pythagorean theorem. I'm subtracting this and finding the distance and finding the distance and then cutting it in half. Okay. Same basic process with midpoint. I'm just going to throw in stuff. So my x2 is 2. x1 is -3. y2 is 2. Right, no, y2 is 6. y1 is 2. Which is worth mentioning. When you're doing the distance formula, if I had flipped that, I actually would get the same answer. That is not the case. So it doesn't really matter if you say, oh, actually, I want this to be my x1 and my y1, and this to be my x2 and my y2, but make sure you're not flipping it. So be consistent and say, okay, my x1 has to be -3, so then my y1 has to be 2. That's where I see a lot of mistakes happen, especially with the midpoint and with stuff with lines that we'll see later on. And so 2 minus -3 is 5. Yep. 6 minus 2 is 4. 5. 4 squared is 16. And so sometimes when we're doing the distance formula, we'll get a nice answer. We'll get something like the square root of 4 or the square root of 36. That's not always the case. This is a good example of, well, 25 plus 16 is equal to 41, and that's not a nice square root, so we stop. And don't have to go in the calculator. You don't have to give me a decimal. This is perfectly fine. Distance is 41, or square root of 41. If this was an application question, yeah, it's a good idea to start doing decimals, but it's not. This is just distance formula. That's my final answer. Any questions? Great. So I'll throw you in groups. If I were you, I would do 1 or 2 of the absolute value equations. Once you kind of get it done once or twice, it's pretty much the same every time. And then on 2.1, maybe 1 of these, and then submit those, and you can call it a day. Have a nice weekend. As I said, we're going to go into 2.2 and probably 2.3 on Monday. So I'll adjust the modules accordingly. And I think those will I'll release the new one. I think I do it either Friday morning or Thursday morning. So outside of content, are there any questions you guys have? Oh, also I'll have my office hours right after this as well. So great. Breakout rooms.